Here are 5 things that you should know for modulus function that took me way too long to realize. But now I'm going to simplify it and present it to you in 30 minutes or less. Okay, let's start. So first, we must know what's the definition. All right, we must know what's the definition of a modulus function. So that's the first thing that we should know. So let's go to the first thing. So first, the definition of a modulus function represented by 2 lines is written as such, curly bracket. It is x when x is more than or equals to 0, and is negative x when x is less than 0. All right, so what does this mean? Okay, so what does this mean here? So this means when x, okay, let me just put a number for x, right? So let's say in this case, x is 4. Okay, so what would the answer to this would be? All right, what would the answer be? So 4 is definitely more than 0, right? 4 is more than 0. So it will be remain as x. So your answer will be 4. Now let's change. What if now I insert negative 4? Okay, so negative 4 definitely is lesser than 0. So lesser than 0. So in this case, it will be negative x. So what is my x? X is negative 4. So negative 4 will become positive 4. So that is the definition. So you should realize absolute value or modulus function, it will make a negative number become positive number. Positive number, it will remain as positive, but negative number, it will become positive number. So another example would be, let's say absolute value of 2. I will get 2. All right. Absolute value of 2, I'll get 2. Absolute value of negative 3. Remember, absolute value making negative number becomes a positive number. So negative 3 become positive number would be 3. Okay, so what is this? Is just how you write it out in a mathematical way to writing it out. So you see this is how you define an absolute value function, right? So remember, absolute value turns negative into positive. So always remember, absolute value turns negative into positive, to put it simply, right? So what about positive? It turns positive into positive, so no change. It only turns negative into positive, right? So remember this. Okay, and one more thing you should know for the definition of absolute value is a function. It's a many-to-one function. So there we go. It's a many-to-one function. Now, why? So remember, many-to-one functions, that means there's multiple different inputs. Multiple inputs have one output, right? Many input have one output. That means, okay, for example, absolute value of 4 is equals to 4, as we seen just now. Absolute value of 4, negative 4, will be equals to 4 as well. Can you see that 4 and negative 4 are different inputs, but it resulted in the same answer, which is 4. Same answer, but the inputs are different, 4 and negative 4. So this is considered as a many-to-one function, right? And yes, it is a function. All right, absolute value, yes, it is a function. So to conclude, for point number 1, what is an absolute value? It turns negativity into positivity. Always remember that. It's a very happy function, right? And it's a many-to-one function. And yes, definitely it is a function. Okay, now what about point 2? Point 2 is algebra. So obviously when you learn a new mathematical notation, you should learn how to use algebra to solve it, right? So example here, I have written 2 equals to modulus x plus 1, and you need to solve for x. So how can we do that, right? This is one of the important part of knowing what a modulus function. You need to know how to solve for x using a modulus function, right? So point number 2, example, 2 equals to modulus x plus 1. All right, so how do we solve it here? Okay, so to solve this, let's go back to a previous example. Let's say a modulus x equals to 4. Now, can you tell me what would be the possible values of x here? What will be the possible values of x? So if you look at a previous example, here, doesn't that mean that in order to get an answer 4, there are 2 possibilities? Either x can be 4 or -4, right? Isn't that true? If I insert 4 into this absolute value function, what will it give me? It will give me back 4. But if I insert -4 into this absolute value function, what will it give you now? It will give you 4. Yes. So these two are answers for x. So as you can see, it can have multiple answers. One positive one and one negative one. So keep that in mind. This is a very important concept. Absolute value, when you have these 2 vertical lines, it can have 2 possibilities. It can either be a positive number or it can be a negative number. So whenever you are solving it for algebra, when you want to remove these vertical lines, remember there's 2 possibilities, positive and negative. Okay, now how do we solve it actually? So let's rewrite this equation. So modulus x plus 1 equals to 2. So remember this one, there are 2 possibilities, right? 2 possibilities, one positive and negative. So that is what you should do. You should split them. So one is the positive version, x plus 1 equals to 2, and one is a negative version, negative x plus 1 equals to 2. Keep in mind, the negative is for the entire thing. So the entire modulus is where the negative is for, right? So let's solve it one by one. Let's look at the positive side first. So positive side, I want to solve for x. The 1, I move it over. I will get x equals to 2 minus 1. Therefore, x will be equals to 1. That's one of my answers. What about the negative side, right? So negative side, remember the negative is for the whole thing. Remember to distribute it into the function itself. So distributing it or multiplying it by negative times by x, I'll get negative x. Negative times by positive 1, I'll get negative 1 equals to 2. So isolating x, moving negative 1 over, I'll get positive 1, 2 plus 1, and therefore I'll get x as negative 3. And finally, your answer would be x is 1 and x would be negative 3 as well. There are 2 answers. So how can we verify this? How can we verify this? Oh, there are 2 answers, but how do we know that it's correct, right? So substitute back into the equation. So x plus 1 modulus equals to 2. So when x is 1, substitute the equation. So modulus 1 plus 1. Okay, what do you get here? 1 plus 1 is 2. So you get modulus 2. Modulus 2 is 2. So yes, indeed, it is 2. What about when x is negative 3? When x equals negative 3. So modulus negative 3 plus 1 equals to negative 3 plus 1 will be negative 2. Modulus negative 2. Modulus negative 2 will give you, yes, 2. And there you go. Both of the answers both of the x values will definitely result in 2. So making x equals to 1 and x equals to -3 an answer for this function. Alright, so that's how you solve for absolute value algebraically. Okay, so that's the second point. What about the third point? Let's look at the third point. So the third point is sketching a graph. So similar to anything you learn in math, anything you learn, you need to know how to sketch a graph, right? You know how to sketch a graph. So there are two types of graph you need to know how to sketch. So let's take a look at it. Point number 3. Okay, first of all, let's think, what does an absolute value graph looks like? Okay, so you should know the most basic absolute value graph would be y equals to absolute value x. So this graph will look like a V shape. So this is your x and y axis. X and y axis. So your absolute value graph will look like a V shape. Right, V shape. So this would be your absolute value graph. Alright. So that's your most basic graph. Remember, it looks like a V shape. No matter what is it, as long as it's a V shape. That's the most basic one. So now, how do we sketch? What if they given us a random equation? For instance, let's say they given us y equals to absolute value of x plus 2. For instance, they given us this equation. How can we sketch it now? So remember, there's 3 steps, right? 3 steps. Okay, let's do the first step. You let y equals to 0. Second step, x equals to 0. And third step is a bit more complicated. You need to use y equals to the y-intercept. Okay, so how do you find the y-intercept? Y-intercept you found from here. When x equals to 0, you'll be able to find the y-intercept. So you found the y-intercept, use back the y-intercept, and make the equation equals and solve for x. That's the 3 steps. So now, how can we sketch it? So let's do it out. Let's write everything out. So first step, y equals to 0. So use our equation here, set y as 0. So 0 equals to absolute value x plus 2. So in this case, from the previous example here, you need to solve for x. You know you need to split it into two possibilities. So positive and negative. So positive side, I'll get x plus 2 equal to 0. Negative side, I will get negative x plus 2 equals to 0. All right. So from here, I will know that x equals to -2 and negative x minus 2 equals to 0. X will ultimately be equals to -2 as well. So you notice something. The answers are the same. When it is equal to 0, you do not need to split it because the answers will be the same, no matter you split or don't split. So to save your working, to save your time, if you notice it's equal to 0, you better don't split it to save your time. But if you want to be safe, you split it anyways, right? So let's erase this. Now we know when it's 0, x will be -2. Okay, so x will be -2. So this is your first coordinates. -2 and 0. What about when x is 0? The second step. When x is 0, so when x is 0, you set x equals to 0, and you solve for y, you get absolute value of 2, which is just 2. So you got your second coordinates. Okay, second coordinates. This one here is your y-intercept. Okay, that one there is your y-intercept. So third step, you need to let your y equals to your y-intercept. Okay, so this is your equation. So let y equals to y-intercept, in this case is 2. So let it equals to 2. 2 equals absolute value x plus 2. So this case you need to split. Definitely you need to split. So one positive, one negative. So what will be x plus 2 equals to 2. At the end of the day, you get 0. So the negative one would be negative x plus 2 equals to 2. And finally, negative x minus 2 equals to 2. And finally, you get your x as negative 4. All right. So if you notice, x equals to 0 is what we already have here. So what we already have here. X equals to 0. So we don't need that. Now what we need is x equals to negative 4. This one. Okay, so now we have our third coordinates. So third coordinates will be negative 4 and 2. So there we go. We have our 3 coordinates from our 3 steps. Now, how do we sketch the graph? All right. So now we just need to replace all of the coordinates into the Cartesian plane. So looking at the coordinates negative 2, negative 4, and 0 is on the negative side of the graph. So what I'm gonna do is use a pen, sketch it on the white paper itself, not a graph paper. Yeah, remember, not graph paper. Sketching you need to do on a blank space provided in the exam paper, not a graph paper, and using a pencil. Okay, so I know it's on the negative side, so I'm gonna draw it like this. Label your graph 0, y-axis, x-axis. Now label the coordinates. So what you can do with the coordinates is you can use your ruler. Maybe it's like 0.1 cm is 1, or anything like that, to have it to be a bit more accurate. Yeah. So, but for this case, I'm just gonna eyeball it. So label your coordinates. So negative 2 and 0. So maybe my negative 2 will be somewhere here. Negative 2, 0. That's first coordinates. 0 and 2 is probably will be somewhere here. There will be 0 and 2. 2 and negative 4 and 2. So negative 4 probably would be somewhere here. Negative 4 and 2. So you can draw dotted lines to connect them up. So there we go. And then there's 3 points. Remember, it's a V shape, so connect them accordingly in a V shape. So there you go. There's your absolute value graph. Finally, label your graph y equals to absolute value x plus 2. And there you go. That's how you sketch a graph, right? Okay, one more thing for graph. One more detail for a graph. Now, what if I modify this equation? What if now I modify this equation? Let's say now the equation is y equals to absolute value x plus 2 plus 1. I added a 1 behind. Now I modify it like this. So how can I sketch it now? Okay, when you see this, don't worry. Sketch it as usual. Pretend as if the 1 is not there. Right? Pretend as if the 1 is not there. Okay? So when you got the rough shape, don't sketch it officially yet. Okay? Just know the rough shape of the graph. You look like this. Just know it. And now let's deal with the behind number. So if it's plus, means go up. Okay? If it's plus, means it's go up. If it's minus, means it's go down. So let's say plus by 1 means it's go up by 1. If it's minus by 1 means it's go down by 1. If it is plus by 2 means it's go up by 2. Minus by 2 is go down by 2. And so on. You see the pattern? So what I mean by go up or go down? So you should know where the vertex is. Okay, so let's look at this graph. The vertex. vertex will be the pointy part, the V shape. There we go. That's the vertex. The vertex will be the pointy part of the graph. All right, that's the vertex. So locate the vertex. Okay, and the y-intercept. Locate the y-intercept. In this case, the y-intercept is here, 2. So locate that. This is the y-intercept, and this is the vertex. So locate those 2 points. Those 2 points must move up by 1. Plus 1 means move up by 1. So those 2 points must move up by 1. All right, so let's sketch it. So first of all, label your graph 0, y-axis, x-axis. So if the vertex move up by 1, I will no longer be at 0, I will be at 1, correct? So let's say 1 will be here. So, and then let's say it's -2. So it moved up by 1. So no longer I'll be at 0. Instead, I'll be at 1. So the vertex will be here. Oh, what about my y-axis? So y-axis is at 2. So moved up by 1, it will be at 3. So let's say this is 2, this is 3. So it will be here now. It will be at 3, moved up by 1. All right, and this will remain the same. It will be at -4 here, and it will be at 3. Remember, everything moved up by 1. So draw the lines, connect them, get your 3 points, and connect them. Okay, so there you go. You got your graph. You can see it's kind of like floating. So yeah, that is what it +1, -1, or any number plus minus will do to the graph. It will be floating. So yeah, so that's how you sketch when there's an extra number behind that's outside of the absolute value. So that's all you need to know for graph sketching for absolute value graph. Remember, it's always a V shape. And remember, if behind there's a number, plus or minus, means it's go up or down. And the number is going up by how many and going down by how many. All right? Okay. Now let's look at the fourth point. What is the fourth point? So fourth point here, negative absolute value x. So this has a meaning. So let's look what is the meaning of it. Okay, fourth point, negative absolute value x. Remember how I told you absolute value is always positive. Always positive. This is true. No matter what answers you get out of an absolute value function, it's always positive. It's impossible for you to get a negative answer out of an absolute value function. Right? Make sense? Let's say I give 2. The answer will be 2. 2 is positive. Or absolute value, -3. The answer will be 3. It's also positive. Is there any chance where I get some number and I get it as a negative number, -1, let's say? No, impossible. So absolute value function always make the answer positive. That's what you should know. All right? But now, is there a function that always makes the answer negative? Yes. And this is that function. Negative absolute value is always negative. Always negative. So let's think of it like this. Absolute value is always positive, and something that is always positive, I put a negative symbol in front of it. Doesn't that make it always negative? Yeah? So let's think of it like this. Negative absolute value of 2. So absolute value of 2, I'll get 2. And negative of that would be just -2. Let's say negative absolute value of -3. So absolute value of -3, I'll get 3. Yes. And negative of that, negative of 3, will give me -3. Lastly, let's say absolute value of 1, negative absolute value of 1. Absolute value of 1 will give me 1, and the negative of that will give me negative 1. Can you see how it's always negative and how here it's always positive? So that's the difference. This is the always positive version, and if you put a negative in front, this is the always negative version. One more thing for this, the graph for this always negative version, it will look like an upside down V. All right, upside down V. So the most basic graph would look like this, upside down V. Y-axis, x-axis, and this is y equals to negative absolute value x. So it will look like an upside down V. Why? Because it's always negative. You can see it's on the bottom of the x-axis, suggesting that it's always negative. Meanwhile, the always positive one, we saw it, is a V shape. It's always on top. It's always on top of the x-axis as it's always positive. All right. So that's what you should know. For this, there's a function that's always negative. So just keep this in mind. Okay. Now let's go to the last and final point. Point number 5. So point number 5 says apply to non-linear graphs. Apply to non-linear graph. So now what does that mean? Let's look at it. So all this while we have been looking at linear graphs, a line, correct? So let's look at how it actually works, how an absolute function actually works. So let's say I have an equation, y equals to x plus 1. So we all know how to sketch this function, right? So this is the y-intercept, and let's find the x-intercept. So to find the x-intercept, I need to let y equals to 0. So y is 0, x plus 1, x would be equals to negative 1. So that's the x-intercept. So let's sketch the graph. So the graph would look something like this. It's a straight line graph. I'm sure all of you are familiar with this. It's a straight line graph. Okay? Straight line graph. And here is 0. So what does this have to do with absolute value function, you might ask? So now imagine, what if I absolute function the graph? What if I modulus this graph? Instead of this, I use y equals to absolute value the entire thing. Okay, keep in mind it's the entire thing I'm absolute value. Say entire thing. So what happens? So now remember what happens when absolute function is applied. Negative will turn to positive. Positive will remain positive. So let's look at this straight line graph. What happens? Which part of this graph is negative? Here, everything below the x-axis. Am I right? Everything below the x-axis is negative. Well, everything above is positive. Am I right? So what the absolute value function is gonna cause it to become, the red part, the negative part, will be converted into positive part. So let's draw it out. So this is the line graph. So the negative part down here would be converted into a positive part. In other words, it will be flipped upwards. It will be flipped upwards. Or you can imagine it as being reflected. So it will be reflected upwards. It will be converted into the positive part. And what happens to the positive part? It would remain. It would remain. Remember, absolute value function does not change positive. It only changes negative into positive. It will remain. And now you can see, why does an absolute value function have a V shape? Because the negative part has been flipped or reflected upwards into positive, making it a V shape. You can see the bolded graph here. The bolded graph here is a V shape. That would be your y equals to absolute function x plus 1 graph. It actually flips it to become positive. Okay? So that's for a line. Alright, so let's talk about a quadratic equation for a non-linear case. So let's say you have an equation y equals to x squared plus 3x plus 2. So for this case, you get your roots as x plus 2, x plus 1 equals to 0. Your roots would be x equals to negative 2 and x equals to negative 1. So those are your roots. Alright, so let's sketch this quadratic graph. So since your roots are negative, I know that it should be at the negative side of the graph. So negative 2, negative 1. So I will know it would look something roughly like this, right? So this is your y and this is your x-axis. So it will look something roughly like that. Okay, now what if I apply absolute value function? Now I apply y equals to, I absolute value the entire function. Absolute value x squared plus 3x plus 2. So can you take a guess what will happen to the graph? So if you guess that the negative part of the graph will be flipped upwards, then you are correct. So how does it look like? So let's check it out. So this is the quadratic function that we are working with. So which part of it is negative? You would say is the part below the x-axis. You'll be correct. Yeah. So how will it then look like? So the positive part will remain. Positive part will remain. So now the negative part, it used to be here, but no longer there. It's no longer there. It has been flipped upwards. So what you see is it will look like this. It has been flipped upwards. This has been flipped. Why? Remember, absolute value function always changes negative into positive. Absolute value function always changes negative into positive. So it has been flipped or reflected upwards. So this would then be the graph for absolute value x squared plus 3x plus 2. Okay, let's look at another example. What if now I have y equals to negative absolute value x squared plus 3x plus 2. Now remember, what does this do? Negative in front of an absolute value function, it makes it always negative. Yes, it always makes it negative. So now how would the graph look like? So you should know the original graph looks like this. This is the original graph. So now everything will become negative. So which part will flip now? Yes, the positive part. Positive will become negative. Negative will remain negative, right? So the positive part will flip downwards. So it will end up like this and like this. So your graph will looks like this. It used to be here. It used to be here. but it flipped downwards. Why? Because absolute value with a negative in front makes it always negative. So the graph would just look like this red part here. So this red part would be the graph. So what graph will it be? It will be the y equals to negative absolute value x squared plus 3x plus 2 graph. Right? So that concludes the 5 points that you should know for absolute value. So whenever you are dealing with absolute value, remember these 5 points. So first point, what is the definition? The main definition is it changes negative into positive, and this is how you write it. This is how you write it out. Second one, how do you solve algebraically for x using absolute value? Third, how do you sketch the graph? There's 2 ways of sketching the graph. So first way is the basic way. The second way would be there's a number behind, either plus or minus. So you should know plus is going up, minus is going down. The fourth point would be an always negative function. Negative in front of the absolute value function would be always negative instead of always positive. And lastly, when it's applied to non-linear graph, you should know the base definition of absolute value function. Why the graph looks like a V shape is because the negative part has been flipped. The negative part has been flipped to positive part. That's why it resembles a V shape. And applying that concept of flipping it into a non-linear case like quadratic graph, you can see there's a lot of weird shapes that will be generated using absolute value. So the negative part will be flipped into the positive part, or if it's an always negative graph, the negative in front of the absolute value, the positive part will be flipped into the negative part. And by doing this, a lot of weird shapes will be created using the absolute value for non-linear. So this is the most basic definition that you should know and how you should apply it. Any kebab questions or any hard questions that need you to know how the fundamental of absolute value function, you know how it works. This is the basic, this is the fundamental. So remember these 5 points, the must know for modulus function. Right? So hope you have learned something and see you all next time.